In this video, what I would like to do is run through a new topic about compression and have a look at a variety of things. Now, as this is a foundation level, what I'm looking for is for you to work through any keywords that I've got, anything underlined or in bold, and definitely if there's any visuals such as graphs, and this one is very, very important. Any graphs, make sure that you screenshot or write these down. Okay, so the first thing is this, about compression. How this works out really is this. You've got a waveform, which obviously that you've got here, and basically you have this idea of waveform before compression. And what I want you to notice about this is that you have these transients here, and I'll go into more detail about what a transient is in a second. But notice these peaks, and notice that when I use after compression, so now this one is going to be after a compression, that I now have these peaks. And do you see how they've been limited or in a way reduced? That essentially is what compression is. Now, I want to really drive this home, which is compression is really about one thing, which is dynamics. And this is massively important. Whenever you see on a test or whenever I talk about anything regarding volume, the volume is about compression. It's about trying to control the peaks, and the peaks are going to be what they are in here. So basically what a compressor does is it just reduces this volume. And as you can see here, that it reduces this volume here, going from this up into that. So this is all about gain reduction, and what it is basically, it's just going to reduce the output of this so that it's a little bit more in tune with the input. So I just want to reference this graph about what I'm writing on here, which is basically this: that the y-axis here represents volume, amplitude, dB. And the x-axis, which is down here, is going to represent time. Now, one thing I want to mention about this, Edexcel haven't asked about this type of interface, but if they ever do, you now know what the x and the y-axis is. One thing I want to mention to you as a reminder that keywords are going to play a big part in this, so make sure that you write down anything about keywords, and I just went through what the x-axis is. This is roughly the exact same thing. However, what you'll notice now is that I've got my keywords in here. The x-axis, let's just do that one first. The x-axis, now this is a brand new graph, and what I want to draw your attention to is the x-axis, which is going to be here on the horizontal line. This is the input. Notice how this is, the measurement of this is in dB or decibels. This is the input level that you're going to be inputting into your computer, or inputting into a compressor, or inputting into any hardware. This is the output. So the y-axis is going to be the output. Input and then output. The main thing to take away from this is that all of this is roughly the exact same thing except for these things. The x-axis is input level, always measured in dB. The y-axis is going to be output level, which again, measured in dB. That is very, very important. Now, regarding this graph, I will be going into more detail about this, this type of graph, but just notice that, yeah, with these output and the input, that's the main thing, the x and the y-axis. So, transients. I've mentioned transients in my classes a few times, and what I want to do is go into detail about what exactly this is. A transient really is this large peak here. And you can always tell a transient because it sort of like peaks on the y-axis and then goes down. So as I mentioned here, it's of a short duration. In other words, that it doesn't go for very long on the y-axis or the x-axis or the time. The thing to take away about transients is that it just gives you a visual, the visual side of looking at a waveform. So you can identify if this is a drum or a bass or a vocal or whatever it is. And it'll give you a hint about what that instrument is. Transients are the loudest part, as you can see, because again, this y-axis is going to be volume. So you can now see that because of this peak up here, this peak down there, that's going to be the volume of this. To control the volume. So again, what I'm trying to do is control these higher parts here, these louder parts, with these quieter parts in there. And the one way to do that is with a device called a compressor. And what a compressor will do is it basically just reduces these peaks, right? It reduces these peaks to make them more in line with these quieter parts. So you can control these louder parts and leave these quieter parts alone. Again, make sure that you're writing all these keywords down. Now, I would like to get into some controls and some keywords about every compressor that you're going to see. This is a threshold. And what a threshold basically does is it tells the compressor when to activate. In other words, it needs to tell when the transients, and let me just put these little markers around these transients again. It basically says when these transients go above that threshold, and the threshold is this line right here, right? So when it goes above that threshold, that's what we need to reduce. That's what we need to take down. So when this sound wave comes in and it goes above that threshold, basically what the threshold is going to do is it's going to reduce those transients. Again, to make the peaks with these transients in more line with the quieter parts. The next term is going to be ratio. And within a ratio, basically now that you've identified with that waveform, the threshold, all those peaks and such, you now need to figure out how much of the reduction. So is it going to be 1 decibel, 2 decibel, 5 decibels that are going to go below that threshold? And the ratio will determine how much is going to be reduced. Now, one thing that I do want to mention, and this is very, very, very important, are the way that this has been written, as in 1-to-1. Notice that the higher numbers on the left-hand side, that's very important for you to write down within all of these. And whether it's an 8-to-1 or a 16-to-1 or a 25-to-1, the higher number will always be on the left-hand side. So I just want to go over this again. Basically what this is you've got now an output level, and again, that's going to be your y-axis. And then you've got an input level, and that's going to be your x-axis. Be aware that this 0 is 0 dB, which means that you're going to hear nothing at all. And this is going to go higher for the output, and this is going to go higher for the input. On this graph, and I'll go into more detail about this in a second, you have this line that goes from 0 all the way diagonally up. And what this is it's an uncompressed way of reducing a waveform. The only thing you have to take away from this is that if you see a line diagonally going up like this is what they call a 1-to-1 ratio, and that means it's being uncompressed, which means the compressor is doing nothing at all. Now, as you can see with this line here, when this line here starts to bend towards now this threshold line here, and the lines get closer and closer to that threshold, but never touching that threshold, because that will be what's going to be reduced. That basically what you have now are these ratio settings getting closer and closer to that threshold. And if you were to see an 8-to-1 or a 16-to-1 or whatever else, it would be just below that 4-to-1. And what I want to also mention about this, which is important, are different typical settings. So for an acoustic, either vocalist or a guitarist, whatever else, you might want to consider a 2-to-1. Which isn't a lot of reduction. However, for a rock recording, which is going to be quite loud, you might want to consider a 4-to-1. And a 4-to-1 is going to be quite a lot of reduction past that threshold. So I really want to get into a little bit more detail about this. And again, let's just go back on these terms. The y-axis is going to be the output. The x-axis is going to be the input. You have 0, so this is going to be no sound whatsoever. And the sound will get louder on the y-axis or louder on the x-axis going from here. So basically, again, what you have are these uncompressed signal. And what I want to remind you about is that if you have this diagonal line here, that means it's been uncompressed. A 1-to-1 means no compression whatsoever. It's just a straight line. But can you see that at this peak, right? So this is the output, don't forget, right? So at that peak, can you see that a 1-to-1 isn't reducing any of my volume at all? But look at this, a 2-to-1. Now that reduction is here. So basically that output, which is here, is now going to be going from the highest peak now to its middle peak here. So that's what a 2 to 1 does. It just reduces this down. And as you can see, a 4 to 1 is going to reduce that down even more. And if you had 8 to 1 and a 16 to 1, it would keep reducing it down and down and down. The purpose of this is to identify different ratios in the amount of compression that is applied. So in other words, if you have a higher number, so this is a 2 or a 4 or an 8 or a 16, the more compression that you're going to have, the further down. A lot of information to take in here, so I'll just pause for 1 minute while you write this down, or indeed if you need to pause the video. 2 terms, attack and release. And basically the attack identifies how fast that the gain reduction will take place. And the release is how much it will go back, how much the compressor will go back to not reducing any signal at all. So let's just have a look at this attack. And basically what I've done is I put an arrow to the attack here and the attack here. Now can you see that on this fast attack here, can you see that this is really going quite fast down? So in other words, that compressor will kick in quite fast. Whereas this slower one here, it sort of goes down like this and it's more of a slope. That's because we have a slow attack. And the same thing goes for the release. The fast release, you can see that it goes right back up to that volume and there's going to be no time being spent getting it back up to its normal volume. Whereas with a slow, it's going to gradually go back up. One thing to mention here is that the terminology, fast and slow. So that's really the sort of settings that you're going to use for the attack and the release. Having said that though, just be aware that you're also going to be working with milliseconds. So this could be a 5 millisecond, a 25 millisecond, etc., part that you'll use. This is merely to show you just a visual. So all I want to do really is just have a look at what a signal would look like, just so that you can sort of understand this in a more visual way. So not much to write down about this. Can you see that this is your threshold? And again, as a reminder, everything above this threshold, and I'll just do this in red, everything above this threshold is going to be reduced. So the threshold will determine where I'm going to start reducing this signal. The ratio, which is here, is going to determine how much is going to go down. The attack here is how fast that we're going to have the threshold activate. And the release is when the threshold will go back to its normal settings. In other words, that the compressor won't work. This is another one that I just wanted to show you. And again, I'm hoping that these visuals will give you some type of insight into how these works. So let's just look at this input of this waveform. So basically what I want to do is, you can see that this is quite loud, right? And what I want to do basically is I want to take all of this and reduce it back down to a normal level. And I'll just say that this is our normal level. So I want to reduce everything that goes above basically this threshold. So be aware that you have a reduction, again, a gain reduction. This is what I'm going to reduce here. And as you can see, what happens at this, now the output of this, once the threshold is, or the compressor is activated, you can see that your sound goes here. And when that peak hits, because of the fast attack, it'll bring it right back down. And again, I want to bring this back to a threshold. Your threshold is also here as well. So that threshold is what's going to determine that no sound goes above this. Now, what you can see is that when this sound goes back down, as in here, it'll take a little bit of time for it to go back up to its normal settings. And this is your normal settings here, just like that. The main thing to take away from this are these key words about what a threshold is, what release, attack, gain reduction, and definitely ratio. If there's any questions, do let me know.